Good morning.
Good morning.
Hello.
Hello, guys. Hello. I was quite busy yesterday, but quite late. I sent you a link to our yesterday's lecture. I hope you received that. Did you?
Yes.
Good. So today is the 7th. So Andrew, Tima,
Hello.
hi, Lorraine,
Here.
Lynn,
Here.
Juanita,
Here.
Christian, Giran,
Here.
Gabriel, Divina,
Here.
Kobe, Chantal,
Here.
Ricardo, Hochito, Gongsi,
Yes.
Kyle,
Here.
Matthew,
Here.
excuse me, Matthew,
Here.
Julian,
Here.
Nathan,
Here.
Alejandro.
Here.
Okay. A little bit later, I will do that the second time, but so far, I will start my lecture. Do you want to ask me about anything? I'm planning to solve some short word problems from this section today, but
Professor, I have a question.
excuse me,
I can't see homework 16 in Wheelie Plus.
I cannot hear you. Can you talk a little bit louder, please?
Okay, I can't see homework 16 in Wheelie Plus.
You know what? You don't need to worry about 16, but actually, it should be available for students. Something is wrong with maybe what you do or with your computer. What about others? Could you see homework number 16?
I cannot see it.
Okay, I will try to check, but this is about the trigonometric actually material. So don't worry about that so far, because I just wanted to show you before I start that reviewing trigonometry, because it is about radians, conversion into degrees, trigonometric definitions of trigonometric functions. Okay.
Okay, thank you.
Yeah, but I will check it one more time. Maybe there is some kind of glitch. If there is a problem, I will call Wiley Plus. This was the problem which we solved last. So, and I will try to choose another part from this problem number 54. And after that, I will move to word problems. This was on page 213. And we had to match the formula to the graph provided here. If we, let's say, look at part D, what do you have in part D? Let's say we solve part A, This time it is part D. And in the part D, in problem number 54, our equation was limit x is approaching negative infinity, f at x equals to 0. Limit x approaching negative infinity, and here limit of f at x equal to 0. What would you like to tell me about your answer here? So you need to look at all these graphs to see which tail of these graphs is running toward negative infinity. At the same time, vertically, it should be approaching 0. What do you think? Which of these graphs is the best match for this answer?
Can it be both 1 and 2?
X is approaching negative infinity, and here it is equal to 0. Yes, actually, number 1 also can be working here, and number 2 also, because in both cases, x is approaching negative infinity. At the same time, here, y is approaching 0. Only the difference is in part 1, it is approaching 0 from the right. Here, we do not see in the answer that limit is equal to 0, let's say from the right, which means from positive sides, from positive numbers to 0. Or let's say it is approaching 0 from the left, increasing from negative numbers to 0. I would like to say that both versions probably will work, in number 1 and number 2. Okay? With your permission, can I move to another material? I mean, from the same section, solving word problems like applications of logs.
Yeah.
Let's start with quite easy problems. Let's say on page number 210, you have problem number 17. Problem number 17. What do we have here in directions? In exercises 17 to 21, find the hydrogen ion concentration, and it has a symbol here, Hv+, for the substances, and here we have a hint. In this hint, we have a formula. In this formula, you can see that log symbol. Okay, I'm going to write it down. 1 second, please. I'm going to copy the formula first. I need to grab scratch paper. So number 17. So here, first H plus in these brackets, this is, you can write, this is the hydrogen ion concentration. We need to find this concentration, but what kind of formula we will be using? Formula here is pH equals negative log of that H plus in bracket. So, and let's see what we have here. In number 17, pH equal to 0. pH is equal to 0. Then I'm going to plug, instead of pH, 0 in our formula. So it will be 0 equals negative log, this is the decimal log of H plus. Definitely, I can absolutely easily get rid of that negative sign. Up to you. Multiplying both sides by -1, dividing, not big deal. So what do we get? 0 is equal to positive log of the same thing, H plus, that concentration. And now we have a very, very simple logarithmic equation. We cannot simplify this more than that, but we can get rid of this log. What is the base of that log? Is it 10?
Yes.
Right? What should we do now? How can we get rid of this logarithmic form? We need to convert this into exponential form. It means log of that number, which is represented by these brackets, should be equal to the base of that log, which is 10, raised to the power, because logs are exponents, which means it will be H plus in brackets equal to 10 to the 0. 10 to the 0 is 1. So which means that concentration here is 1 mole per liter. That's it. We solved the problem. I wish all that problems were like that. So practically, formula is provided and you are just plugging your data, and after that you have in your possession quite simple logarithmic equation which you have to solve. I'd like to show another also application, and there is about, let's say, concentration, level of sound, magnitude of the earthquake. There are so many different applications of logarithms. Yeah, I will try. Guys, I don't have a coronavirus. I have horrible allergy. And besides that, we all the time sit mainly inside of our residences. And I just had 2 hours lecture in my 3 class. This is why my throat, well, excuse me, please. I really apologize. So I'm going to ask you to look at one of problems here. And let's say this is problem number 44 on page 213. Can you read, please, that problem? The noise level of the whisper is 30 decibel. Oh my God. Configure the sound intensity of a whisper. Can I go to drink some water? I really apologize. I need to drink. Оля, ты мне водички можешь дать стаканчик? Потому что я задыхаюсь от кашля. Я не закончила даже. Миша, водички дай срочно, я задыхаюсь от кашля. Так, ты несешь или нет, Миша? Миш, ну скорее, меня студенты меня ждут. Меня приступ начался. Спасибо. I really apologize. So, this problem also has a formula which is provided here in your textbook. So, this is noise level in decibels. I really like to ask you to look at the formula first. And this formula also, you can see, has logs. Okay. What do we have here in this formula? It is the level of sound in decibels measured in comparing to the sound intensity I to a benchmark sound I0 with intensity of 10 to the negative 16 watts per centimeter squared. So noise, I am going to use the abbreviation, noise level, like NL, equals 10 times log. We are dealing here with decimal log again of the ratio I to the benchmark noise level, I0. Noise level. This here I0 is equal to 10 to the negative 16 power watts per centimeter squared. And now, being equipped by this formula and this information, we definitely can solve this problem. What about that whisper? The noise level of a whisper is 30 decibels. So which means NL is 30. We're going to plug this into that formula. So 30 equals 10 times log of that ratio. And our goal is to solve this equation for I. Can we simply divide both sides by 10?
Yeah.
So let's do that. So it will be 3 equals to decimal log I over I0. And again, we ended up here having that very easy logarithmic equation, and this log has base 10. How can we get rid of that log right now? Again, we just simply need to convert this into exponential form. which means that ratio I over I0 equals 10 cubed. 10 cubed. Right here. And we are solving this for I. Can we multiply both sides by I0?
Yeah.
So I equals 10 cubed. I even will not convert this into 1,000 because I0 also has power of 10. In other words, I equals 10 cubed times 10 to the negative 16th. Is it 10 to the negative 13th power? Guys,
Yes.
that's it. We solved that problem. We found the value of I. It is 10 to the negative 13 watts per centimeter squared. Did you understand that process?
Yes.
Yeah.
Excellent. Okay, let me choose something different. I like to show you different type of applications. But again, they are all will be using that models. Okay. I think there is actually a guess about magnitude on the Richter scale. Yes, yes. In the first column of the text on page number 213, you can see the formula with capital M. This is the formula for the magnitude of the earthquake on the Richter scale. M, capital M here stands for the magnitude. And again, it has decimal log. So what do we have here? I'm reading this from your textbook. Problems 48 through 51 use the Richter scale for the strength of an earthquake. The strength the strength W of the seismic waves on the earthquake are compared to the strength W0 of the seismic waves of the standard earthquake. The Richter scale rating M is, and this is the formula which is provided right here. If you compare this formula with the formula of the noise level, you can see they are very similar. So I'm going to grab one of problems right now. And solve. We have here several problems. Let me see which one to choose. Okay, there are quite many. What about, let's say, 49? I saw something what actually familiar, because I several times visited Ukraine, very nice country, but I definitely never was planning to go to Chernobyl because it is a restricted area, nobody lives there, everything is abandoned. And I heard about very nice, beautiful city. The name of that city is Pripyat, where there was an explosion on this nuclear station which produced electricity. So it is very sad, but it is life-related actually problem. I'm going to read that. In 1986, the worst nuclear power plant accident in history occurred in Chernobyl, Ukraine. The explosion resulted in the seismic waves with a Richter scale rating of 3.5. How many times stronger were the seismic waves of the Chernobyl disaster than standard seismic waves. Okay, what should we do? We just can simply apply that formula. The magnitude was 3.5. So M is 3.5. Okay, and what can we do? We can plug it into that formula. So 3.5 equals decimal log of W over W0. This is the first step. And again, applying very easy properties, we can convert this into exponential form. So W over W0 equals 10 to the 3.5. In other words, if you multiply both sides by W0, you are getting W equals 10 to the 3.5 times 80. I need to grab my calculator because I need to approximate 10 to the 3.5 to know how many times it was stronger than the standard seismic earthquake. Okay, so 10 to the 3.5, and you can approximate, let's say, to the nearest 100. Did you get the same number?
Yeah.
Yes.
Okay, let's approximate. So it will be approximately 3162.28 of the W0. Oh my God, it was more than 3,000 times stronger. Or let's say 3.162 times stronger. 3,162 times stronger if we roughly approximate that to the nearest ones. So we solved this problem. Do you understand how to solve these problems?
Yeah.
Yes.
Okay. What do I need to discuss right now? Dear ladies and gentlemen, this was the last, actually, our material in these two chapters, which we reviewed, because again, this is not a new material, this is an old material. So I'm planning to offer you a test, and now I need to ask you the following thing. Today is Tuesday, right?
Yeah.
Definitely. I already talked about this even before the break, that I'm planning to give you a test. I have two options. I can offer you this test tomorrow. I can offer this test on coming Thursday. And I will let you choose and tell me which day do you want to have it, tomorrow or on Thursday?
Thursday.
Thursday.
Thursday. Yeah.
Thursday.
Thursday will be good. So, okay, I let you choose. Where is my telephone? Yes. What? Why? Because again, to just show you, today is the 7th. So which means if you are choosing coming Thursday, it will be April the 9th. Can you please write it down?
Yeah.
That on April the 9th, you will have the test for these two chapters. These chapters are about properties and related material of two functions, exponential and logarithmic.
Professor,
Yes.
since the test is on Thursday, tomorrow, can we have a review class? Like,
I'm planning to review right now also a little bit because we already solved too many problems. I'm really afraid of being very behind, but try to review this material, and I think I will be able to find some time tomorrow also to review some problems, but I'm actually planning to start trigonometry. So I definitely will be solving more problems right now because I will, during that test, you will have what? You will be having material about properties of both functions, and including domains, ranges, asymptotes. Related to this material, we can add that kind of problems like equations. What kind of equations? Exponential and logarithmic, and we solved many of these type of problems, and I'm planning to review right now as well. And simple applications like simple word problems. This is the material which I'm planning, and there is a big chance that you will be having this test using Wiley.
Okay.
Is it clear?
Yeah.
Yeah.
Now, with your permission, can I work with you, like reviewing again for this coming test, solving some probably maybe equations?
Yes, please.
Okay. Let me write it down on the paper. Another thing, what you please try to remember, when we have exponential equations, and even if in the process we have to log both sides, we are not obligated to solve and check. But if our original equation from the beginning was logarithmic, it is your obligation. You have to solve and you have to check. Checking is a part of solving process. Is it clear to everyone? Please
Yes.
Yes.
remember this, it is really important. So can you please just solve the following equations? And let's say this is one of equations. Log of x minus log of x minus 1 equals 1. I'm going to show this to you right now. Log of x minus log of x minus 1 is 1. Did you copy?
Yes.
yes.
Okay. Let's solve. First of all, can you give me the name of that equation?
Logarithmic.
Logarithmic. Why did I do that? I did it purposely, trying to again put some emphasis on this word logarithmic equation. Let's solve. Quite often solving these equations, first we are dealing with, let's say, with logarithmic equations, but we can apply properties of logarithms and convert this into either form of equation. What do you see here on the left side? Do we have logs with same basis?
Yeah.
Yes.
Excellent. Is it a difference of two logs?
It is.
Yes.
You for sure should review all formulas for exponents and logs. If you have difference of these logs, can we convert this difference into something different according to the formula for the log?
Yeah, we can turn it into a fraction.
In which of these formulas you had difference of logs? Is it log of the quotient?
Yeah.
Yes.
So, which means instead of two spots with logs, we can get only one log, but only be careful, this log will be log of the quotient. I converted this difference of, excuse me, I converted this difference into log of that quotient. And instead of two separately standing logs, now I have only one. There is the end of simplification because it is quite simple now. What about this? Is it a decimal log?
Yeah.
So now it is a real good time to get rid of that log. Can we convert this into exponential form?
Yes.
What is the value of the log? Is it 1? So exponent
Yeah.
is 1. What is the base of that log? Is it 10?
Yeah.
Mhm.
And look what we have. We have new form, which does not carry log sign anymore. It is x over x minus 1 equal to the 10 to the first power. Definitely you can just simply write 10 because 10 to the first power is 10. But we changed the nature of that equation. It is not logarithmic anymore. What, by the way, what is the name of that particular equation on the last line? X over x minus 1 is equal to 10. What is the name?
Rational.
Absolutely correct. So look what I'm going to do. I will immediately write next to that. X is not equal to 1. Because if x is equal to 1, I will be having hard time. I will be forced to divide by 0. So how can you write after you took care of that value, or we call it restricted value for that equation? Can you simply multiply both sides by x minus 1?
Yes.
And simplify? And what would you get as the result of that? Isn't x equal to 10 times x minus 1? I just skipped very short step.
Yes.
Can we distribute on the right?
Yes.
So if we distribute, is it x equal to 10x minus 10?
Yes.
Excellent. Can we, let's say, move x from left to right and negative 10 from right to left? Or you can add 10 to both sides and subtract x from both sides, which is more complicated. Moving is much easier. So I just waited for you guys. Now 10 is equal to 10x minus x, which means that 10 is equal to 9x. After dividing both sides by 10, you get x equal to 9/10. Or actually, if you like, you can write 0.9. 0.9. Or 10 over, or well, excuse me, what did, no, please, I really apologize. I am already losing my mind. 10 over 9, and I said 9 over 10. 10 over 9, x is equal to 10 over 9. I really apologize, I made a mistake. But I cannot box it, I need to check. And how can I check? I need to plug this value into original equation. So check. So it will be log of 10 over 9 minus log of 10/9 minus 1 should be equal to 1. I'm not saying that equals to 1. I'm saying should be equal to 9. And I'm going to simplify. Log of 10/9. If you subtract 1 from 10/9, 1, is it 10? Excuse me. 10/9 minus 1 is 1. Is it 9/9? Guys, I did not hear your reply.
Yeah.
In other words, is it log of, right here, you can see log of 10/9 minus log of 1/9 should be 1. But again,
Yes.
we see the difference of 2 logs. And I'm going to convert this into log of the quotient. I need to have log of 10/9 divided by 1/9. But 10/9 divided by 1/9, is it same thing like 10/9 times 9/1?
Yeah.
Should be equal to 1. Can we cancel 9s? Yes? And what do we get? We are getting log of 10 equals to 1. Look at the left value. To which power you need to raise 10 to get 10? Is it the first power?
Yes.
Because logs are exponents. So 1 equals to 1. Is it true?
Yes.
Yes. And we really got true statement. You can see that right there at the corner. Log of 10 equal to 1, which means 1 is equal to 1, which is true. And I have now very good reason to come back and to box that x equal to 10/9. Did you understand every single step?
Yes.
Do you want maybe any other equation? By the way, in your textbook on page 226, you have a bunch of nice looking equations, and this is review exercises. Review exercises, many different actually exercises. You have here equations from number 7 to number 20. You have here equations from number 33 up to, in 34, it says solve for x exactly. There are also equations, even though they do not name that equations. If you have anything here, what catches your attention, just share with me and I can solve. But before you choose, I have time to accommodate your request. I can offer you, if you like, another logarithmic equation, and this is quite interesting equation. Would you like to?
Yeah.
Yeah.
Okay, I'm going to write it down.
Professor, quick question. Will limits be on the test?
Excuse me?
Will limits be on the test?
Very simple limits. This is why I'm not like, look, what is the limit of that kind of something? I have not even decided, maybe yes, but very, very simple cases. More complicated limits will be at the end of that course, our course. So, okay, I actually will choose from your textbook. On page number 226, can you look at part F? Does it look quite complicated to you? Again, page 226, it is chapter review, 34F. Guys,
Oh, yeah.
yes
Yeah.
or no?
Yeah.
Yes.
Again, these are coordinates of that problem. Page 226, 34F. Okay, let me copy. Natural log. Up to you to use parentheses here around 8x. If you do not use parentheses here, it is not a mistake. If I had some sum or difference, you have to use, if it is, let's say, not 8x, it is 8 plus x. In this case, you have to use parentheses. This is your equation. Can I say that it is a logarithmic equation?
Yes.
Yeah.
Excellent. And we have here 3 different spots with logs, but we are quite fortunate that all these logs have same basis. Are they all natural logs? Yes. So let's start. Can you look at the top and specifically at that 2 which stands in front of natural log of 2x? How can I simplify this part? If you have a number as a coefficient in front of the log, can I grab it and change the position of that like an exponent?
Yes.
So let's take it as a first step. So this time it will be natural log, and I will show a little bit more steps because I don't want to confuse anyone. This how these 2 migrated. Now it is right there, exponent for 2x. It is natural log of 8x minus natural log of 2x parenthesis squared. This is square of 2x. It is not square of log. So 2x squared, is it 4x squared?
Yeah.
So I'm writing natural log 8x minus natural log of 4x squared over, and I'm very happy that now in front of each log I have coefficient 1, and now I can continue my simplification. I am again working with the top part of that fraction. Is it a difference of 2 logs?
Yes.
Is it the log of the quotient?
Mm-hmm.
Okay, do that. Take care of that. So it will be natural log of 8x over 4x squared over natural log of x equals to 1. Can you see?
Mm-hmm.
Definitely. Because we are dividing by x, I would write comma here, and I write x is not 0 because I really like to reduce that fraction. 8x divided by 4x squared, it is, in other words, it is 2 over x. But on the bottom of that same equation, I see natural log of x. What happens if natural log of x is equal to 0? It will be a very bad situation for me because on the bottom of the fraction, I will have 0.
Yeah.
This is why I need to exclude that situation immediately. I'm writing on the side that natural log of x is not equal to 0. But if this is the case, it means x cannot be equal to 1. So now I already have 2 bad values, which I excluded, because if natural log of x equal to 0, then that x should be equal to 1. And I cannot afford that kind of situation, because in this case, I will be dividing by 0, because natural log of 1 is 0. I will continue. So the top part now is natural log of 2 over x, because I canceled by 4 and by x, over natural log of x equal to 1. This equation now looks simpler. What can I do here? I, let's say, do not want to have here fractional form. Can we multiply both sides by natural log of x?
Yeah.
Okay. Now it will look like natural log of 2 over x equals to natural log of x.
Hmm.
And I have now both sides in very simple form. I cannot simplify more than that. What should I do now? It is time right now to say very warm goodbye to both logs, because first, they are equal to each other. They have same basis, and according to the property of logs, if two logs with same basis are equal to each other, their numbers under symbols of logs should be also equal to each other. So I am not canceling logs, I'm just using that property, which lets me rewrite this in that form. 2 over x equal to x. The nature of that equation is absolutely different. Now it is a rational equation, but I don't need to write any comment here, because I already assumed that x is not, was not 0. So basically, I need to proceed. Can you multiply both sides by x?
Yes.
It is nice. It is quite interesting equation. This what you are getting. X squared is 2. Can you see? Guys.
Yeah.
So I'm solving this for x. Can I take square root from both sides?
Yes.
And I'm getting x equals positive or negative square root of 2. This is what I got for x's. Is it correct?
Yes.
The voices
Yes.
voices are quite suspicious. Is it strong, yes or no?
Yes.
Yes.
Excellent. But do we have to check? Yes. And I'm going to check right now. Check. First, I'm going to check positive value. So it is part A. Natural log of 8 times square root of 2 minus 2 natural log of 2 times square root of 2 divided by natural, excuse me, please. What is that? Natural log of square root of 2 should be equal to 1. Excellent. I just plug this in. But I probably will not have the time to keep you longer for the second negative value. But when you plug it from the beginning, I will say it will not work, because you will get natural log of 8 times, let's say, negative square root of 2. We cannot have negative numbers for values under any log sign. This is why
Yeah.
checking was very important. You can write down part B. Instead of x, you will be plugging negative square root of 2, but immediately you can write that this value will not work, because we cannot have negative values under logarithmic sign. But what do we have here? It will be natural log of 8 square root of 2 minus natural log 2 square root of 2 squared. 2 square root of 2 squared is 4 times 2. 4 times 2 divided by natural log. And let me just finish this part because checking here is also quite complicated. So, oops, I really apologize. 4 times 2 is 8. And there was a difference of 2 logs, which I will convert into ratio. 8 square root of 2 over 8 over natural log of square root of 2 should be equal to 1. I am going to cancel both 8's, and I am getting here natural log of square root of 2 over natural log of square root of 2 should be equal to 1. In this last part, do you see that we are dividing same thing over same thing?
Yeah.
Yeah.
Is it 1 on the left?
Yeah.
Yes.
Is it 1 on the right?
Yeah.
Is it true?
Yes.
True.
So at least one value worked, and this value was x equal to square root of 2. It is our solution. But you need to finish. I will not finish. I don't have time, but please finish the second part, because for the second part, we are going to deal with negative x equal to negative square root of 2. If you plug this into original,
Yeah.
it will be a violation because we cannot have negative numbers under logarithmic symbol.
Mhm.
Mm-hmm.
This is a good example to demonstrate that checking is very important.
Yeah.
I am done for today. I really apologize that I kept you about 5 minutes longer.
That's okay.
Can I
Okay.
finish, can I finish my lecture? But I did it for your benefit, ladies and gentlemen.
Yeah.
And I really apologize for my bad situation with my allergy today. So I wish everyone a good day, and please be serious about getting really good looking grade for the test, okay?
Okay.
Okay.
Okay, and I hope to see you tomorrow during my virtual meeting with you. Bye, guys.
Bye
Bye,
bye.
Professor.
Yes,
Oh no, I said bye, Professor.
excuse me?
I said bye.
Bye. Huh? Yeah, and I really apologize. All people who names I checked can leave. I don't want to have a symbol of absence for other people. So Andrew, I heard
Okay.
your voice. Andrew,
Yeah.
yes. And who's next? Christian, Gabriel,
Here.
okay. Kobe, Ricardo, Hochital. Okay, that's it, guys. I'm ending my today's session. Everyone, have a nice day. Thank you
Have a
for
nice
being here.
day. Bye bye.
Bye.